Oh, there's so many teachers that keep trying to do this, but it just doesn't work. I think you got it. Should do it again.
Okay. Screen.
So you want to is this one? So that's okay. Anything else?
All right, so is it clear? Okay, so today we're going to look at the compound inequalities. Compound inequalities. So here, for the compound inequalities, we're going to look at the and the or. The and the or. So compound inequalities is made up of two inequalities connected by the word and or, as shown here. So we have the inequality here, x plus 1 is greater than 3, and 2x minus is that one, and also this one for the or. So to solve the compound inequality with the word and, we look for all the numbers that make both the inequalities to be true. Both should be true. Then for the or, we look for either the inequality is true. So this one should be both. This one is either. Okay, for example, here. Solve for 6x minus 3 less than 9 and 2x plus 9 greater or equal to 3. Graph the solution and write the solution in interval notation. Right. So here we have 6x minus 3 less than 9 and 2x plus 9 greater or equals to 3. So we use the steps that we were using last on Wednesday now by solving the inequalities. So we start from the first one. So here. So what you do here, you do what? You add, right? So it will be 6x minus 3 plus 3 less than 9 plus 3. So that one is step number 1. Step number 2, you solve that. So 6x is less than what? 12. So here x is less than 2. Then we come here and so 2x plus 9 greater or equals to 3. So we solve this one again. So 2x plus 9 minus 9 greater or equals to 3 minus what? Minus 9. So here 2x is greater or equals to 3 minus 9 is what? Negative what? 6. So x is greater or equals to negative 3. So that one is the first step. So the next one is now you draw the graph for each one of them. You graph each one of them. So let's start from x less than 2. So you draw that. So that one is 0. That one is 1. That is 2. Negative 1. Negative 2. So x. So we go to 2. So less than is what? It is not included, right? So that means we use the what? We use it, that one. So this comes this way. So anything less than 2. Anything less than 2. Then we come to the next one. So this is x less than 2. So we come to the next. You draw again this 0. So this is 1, 2, 3. Negative 1, negative 2, negative 3. So this is x greater or equals to minus 3. So how will this go? So we know that one, this is what? Included, right? So that means it should be that way, right? So, and then all the values here. So this is x greater or equals to minus 3. Okay, so looking at here, so this is minus 3. Let's say that one is minus 3. So it comes up to this point, okay? Because we are taking the values and we are using the and. So both should be what? Both of them should be true. So up to there, and then also from this point up to there. So it should satisfy that region over there, okay? So what will be the interval notation there? So what will be our common, or how will this satisfy? So this will be 0. Definitely here will be 2. And here will be minus 3. So therefore, it will be like this. And then that one. So this is our region. So that one is our region. So the interval notation will now be this region, which is what? Minus 3. And then what? 2. What do you do here? We close that one. And this one is what? And that one is okay. Are we together there? Anyone struggling? Okay, so So let's try this. Four x minus 7 less than 9, then and 5x plus 8 greater or equals to 3. Try that one. Okay. So we solve this. So we solve 4x minus 7. So that is 4x less than 9 plus what? 7. So 4x is less than 16. So x is less than 4. And 5x greater or equals to 3 minus 8. So 5x greater than minus 5. So x is greater or equals to minus 1. Okay. So then we draw the graph for each one of them. So 0 here. So we have, let's say, 1 minus 1. Then it goes that way. This one is 1, 2, 3, 4. Goes that way. So x is less than 4. So that way. So this one is x less than 4. Then we come to the next one here. So minus 1, minus 2 goes that way. For that. So x greater or equals to minus 1. So minus 1 is here. So greater or equals to minus 1. So this one is x greater or equals to minus 1. So what will be our region? So this is our region there and here. So the one which will satisfy both will now be what? 0 here, 4 there, and then minus 1 here. So this will now be and then that way. So this is our region. So that one is our region. So what will be our interval notation there? So it will be what? Minus 1 and then what? 4. All right? Okay. Any question there? Okay, let's solve this. So 1 over 3x minus 4 greater or equals to minus 2 and minus 2x minus 3 greater or equals to 4. Greater or equals to 4. use the same procedure. So 1/3x minus 4 greater or equals to minus 2 and minus 2x minus 3 greater or equals to 4. Okay, let's solve this. So we take minus 4 to the other side. So 1/3x is greater or equals to minus 2 plus what? Plus 4. So 1/3x greater or equals to what? So minus 2 plus 4 is what? 2. So x is greater or equals to what? 6, right? So we multiply 4 by 3/1, the reciprocal of that. Okay, and this section, so we can open this bracket. So minus 2x plus 6 greater or equals to what? 4. Okay, so make sure you check that sign there. So when you open that bracket, then it will be minus 2x plus 6 greater or equals to 4. So we simplify minus 2x greater or equals to 4 minus what? Minus 6. So minus 2x greater or equals to what? Minus 2. So what do you do over there? We multiply by what? Minus 1, and then we change the what? Yes, we change the inequality. So here it will be 2x less or equals to 2. Now x is less or equals to 1. X is less or equals to 1. Then we draw each one of them. So this is 0. Let's just put here. We can put here 1. Then we put there. Then we can put here 1. And then we put here 6. Okay. Then again, we can put here 1 or 6, minus 6, minus 1, 0, 1, and then 6 there. So x is greater or equals to 6. So we have here 6. So x is greater or equals to 6. So that means it goes where? That direction, right? So this is x is greater or equals to 6. Then here, the next one, and x is less or equals to 1. So this is 1 here. So less or equals to 1. So where does it go? This is x is less or equals to 1. So there is a gap here. And there is a gap here. Then we say for and, both should be what? Should be true. Both should be true. So therefore, in our case, there is no one. There is no solution. So we don't have a solution here because we have a gap over here. Okay? So we don't actually have the solution. Right? Now let's come to another section called double inequalities. Double inequalities. this one is equivalent to and. But now we are just combining the two of them. So this is just equivalent to and. So if we have x here, and then maybe A and here B. So this is the same as A, x, and x less than B. It is similar to that. Is similar to that. Now, if we are given this to solve, minus 4 less or equals to 3x minus 7 less than 8, something like that. And then we are told to graph the solution and write the solution in interval notation. Then what will you do? So what you do here, you make this region to only be the variable x, okay? So here, what you do is, you need to remove all these values here, minus 7 and 3 here. So what you do in this side, you do the same thing in the other side, okay? So in our case, minus 4 less, so what you do outside here, we need to remove this minus 7 here. So what do you do to remove minus 7 here? We do what? We add, right? So minus 4, what you do inside here, you do it in this region and also here. So when you add 7 inside here, then you also add 7 here, less or equals to 3x minus 7 plus 7 less than 8 plus what? Plus 7. Okay. Then you simplify. So minus 4 plus 7 is what? 3, right? Less than or equals to 3x less than what? 15. So when you divide by 3 here, you do it in all the sides. So you divide here by 3, you also divide here by 3, and also you divide here by 3. So what will you get? So you get 1 less or equals to what? X less or equals less than 5. Less than 5. Then you draw that in a graph. So you just go. So this is 0. This is 5. This one is 1 minus 1. Goes that way. So we have 1. So x is less than what? X is greater than what? 1. So, and this one is what? Closed. So it will be like that. And then x is less than 5. And this one is what? Okay. So this is our region. Therefore, the interval notation is what? 1. And then what? 5. Like that. Okay? Are we together? All right. Now let's come to solve compound inequalities with O. Solve compound inequalities with O. So find all the solutions that make the inequality true. So for example, so this is almost similar to and when you're solving the other steps. But when it comes to or, then we see how we solve it. So this is an example of 5 minus 3x less or equals to minus 1 or 8 plus 2x less or equals to 5. So you use the same steps to solve up to the graph. So we make x the subject, so we can take this minus to the other side. Minus 3x to the other side. So in this case, then it will be 5 minus 3x plus 3x less or equals to minus 1 plus what? 3x. So 5 less the minus 1 plus 3x. So we bring this minus 1 to the other side, so it will be what? 6 less or equals to what? 3x. So definitely this will be 2. Okay. So that one is the okay.
I have a question. So if instead of like adding 3x to the graph, you guys instead subtract the 5 and multiply the -3, you still get 2, but in one solution, yes, it's simple, and the other you keep it the same. So, like, how do you know which one to do?
Okay, this one is one of the steps. Another one is you can do it like this. So this is 5x, 5 minus 3x minus 1, right? So you can take 5 to the other side. So you subtract 5, right? So it will be minus 3x less or equals to minus 1 minus what? Minus 5. So minus 3x less or equals to what? Minus 6. So we need to multiply by minus. So when we multiply by minus, we change the inequality. So minus, so it will be 3x 6. So x greater or equals to what? 2.
So it's the same solution, but
It's the same solution. It doesn't matter where you put x. Okay? So here we put x in the other side. So it's the same as x greater or equals to what?
It's because you divided by a negative at the sign. So
Yeah.
I see what you're doing. That makes sense.
Okay. All right. So the next one, this other side. So we can take a to the other side. So 2x less or equals to what? 5 minus 8. So 2x less or equals to minus what? Minus 3. So x is less or equals to minus 3 over 2. Minus 3 over 2. Then you draw each one of them. So you start from this. So this is 0. This is minus 1, minus 2, 1, 2, goes that way. The next one here. So 0, 1, 2, minus 1, minus 2. So x greater or equals to 2. So x greater or equals to 2. So this is the region, right? So x is greater or equals to 2. And 2 is what? Included, right? So it goes that way. So this is x greater or equals to. Then here, x is less or equals to minus 3 over 2. So it's minus 3 over 2, so here, right? Somewhere there, right? So where will that go? Which direction? the negative direction. Right? So it will be like that. So x is less than that. So this is x less or equals to minus 3/2. Now, because this one is odd, then I don't know whether you've learned this thing. Union, this is for or, sorry. And then there is something like that. This is for and. Have you ever learned something like that?
Yes.
No, yeah. So or is the union of that one. Yeah. So the values which, what can I say? The values which are, let's say we have A, B. Yeah. So there are elements which are in A and there are elements which are in B. So for the union, these are the elements which are in A and the elements which are in B and the elements which are in A and what? And B. So that one is OR. Okay? So union. So the elements which are in A, the elements which are in B, and the elements which are in A and what? And B. Then for AND, these are elements which are in A and what? B. So there should be elements which are in A and B, not the elements which are in A and not in B. Okay? So for the OR, those are all the elements which are in A and B. It doesn't matter whether they are in A and B or A alone, like that. So for the OR, we include all the elements. So in our case here, then when we draw the common one here now, then this is 0 here. So let's say -1 there, and then -2 there, and then 1, then 2. So we have values which are going this way for the x greater or equals to 2, and the values which are going this other way for the x less or equals to what? -3/2. Okay. So in our case, then to write this now, we use the union there because those are just the values. There are values which are in the other side and the values which are in this other side. So we combine them. So it will be like what we did last Wednesday. So to write for this, how will we write for this? So it will be what? Minus infinity, right? And this one is not what? Okay. And then we have this region minus what? 3/2. And this one is what? 12. Then here it is what? 2. And then that one is closed. And then this region there, that one is open. And then we use the what? The union there. Okay. So those are the values which are in the other side, the values which are in the other side, and the values which are here, which are not in this and this region. So this is now the OR. Are we together? Okay, try this. So 2/3x minus 4 less equals to 3 or 1/4x plus 8 greater or equals to -1. So this is 2 over 3x minus 4, 3 over 1 over 4 x plus 8 greater or equals to minus 1. All right. Okay, so we take minus 4 to the other side. So 2 over 3x less or equals to 1. Right? Then we multiply by the reciprocal. So x less or equals to 7 times what? 3 all over 2. Okay? So x less or equals to what? 21 over 1 over 2. 21 over 2. So this other side, we multiply both sides by what? 4. So x plus 8 greater or equals to minus 4. Are we together? So you multiply by what? 4 over what? 1. Are we okay there? Are we together?
Yeah.
Okay. So then we take a to the other side. So x greater or equals to minus 4 minus 8. So x greater or equals to minus 12. So this is the region 0. So we can start from this. X is less or equals to 21 over 2. So 21 over 2 is like 10.1, 10.5, right? So let's say this one is, this region is 10, this one is 11. So this region. And this one is what? Less or equals to 21 over 2. So you got that. So this is x less or equals to 21 over 2. Okay, x is greater or equals to minus 12. So we can use the same graph. But for you, use the first step, use the 2 graph, and then you draw the last one. Okay? So here we can use 1 graph. So we can take this as 12, 11, then maybe 10. This is minus, minus, minus. So minus 12, x is greater or equals to minus 12. So this is like that. So x is greater or equals to minus 12. Okay. So here, this one is now clear. This is our region. Up to that point. So this is our region. So what will be our in? What did you say?
It's connected. So there's no view.
Yeah, it's connected now.
There's
That's
no
what you
unit.
say?
There's no bridge.
Yeah, there's no bridge,
Already done.
so it's connected. Okay.
So you would just use negative 12.
Yeah. So now our interval notation will be what?
Negative 12.
Negative 12, and then this one will be what?
10.5.
21 over what? 2. And
So Yeah.
What is he saying?
He's saying, wouldn't it be negative infinity, positive infinity, because it's or it's on an and?
Or and the other one is and.
Like,
That's
if
okay.
they were gonna do things quick and it says it's an or, it would be.
Okay, so let me. This was a shortcut, okay? So so this one was minus 12, right?
Yeah.
And then it was coming this way. So this is x greater or equals to minus 12, right? Is that okay? Then the other one, so this is 0. The other one here, this is 21 over what? 21 over 2. And this one was coming which way? This way, right? Is that clear?
What I'm saying is that since it's or instead of and.
Yeah.
That'll be negative infinity, that's the bulk of what is all of it would be. Just or.
But we have a region. We now have a region, which is this region here. 21 over 2. So we now have this region here. It is connected.
Because of brackets, including just those, that way. That's what it's doing. Oh, yeah. Well, those are different that way, they're one different that way. And then you put brackets. But I guess.
Since the brackets connect, you don't have to.
So
have
you're
that.
trying to tell me, I know what you're trying to tell me. So you're trying to tell me this is minus 12. This is like that. And then infinity here, this is like that. And then union minus infinity, like that. And then 21 over 2. That's what you're trying to tell me. Oh, okay. All right, so our interval notation would be minus 12, and then what? 21 over 2. Okay, we have almost time. So you go try solve those ones, and then if you have any issue, you can write a mail to me, okay? All right, who did not hear is our man? Taking some attendance. There are some people. Avalos is here. Cafe. Martinez, Gillian. Marelle. Padan, Kayla. Peterson, Relay. Rock.
Riley Rock.
Yep.
Oh.
Thompson, Egan. Who did not hear them? What is your name? Riley. Who? Pearson. Okay. Who else? Okay, did you finish your homework? who hasn't done any? I saw like 29 people. So you've done section 2.5 and 2.3. Okay, so you can go and do section 2.6. All right. Okay, see you on Monday.
Sorry.
Yeah, I get your point. I
It's like,
understand now.
because it's and or,
Yes, yes,
I was thinking because it's all that's there and all that's there.
yeah.
So I thought the solution was negative infinity
Mhm.
to infinity.
Yeah, that's true. I confused with that.
Yeah, that's what I was
Yeah.
saying. I was like, and would be this solution,
Mhm.
but that would be or.
Yeah.
Wouldn't it?
This one, that one.
Okay.
Yeah.
Okay. He's right.
Yeah, he's right.
Hey, I wanted to see if you got my name down. Because I was going to say my name is Grecia Avalos.
Okay, which one is the name?
Probably this one right
Oh,
here up
okay.
top. Because I heard you say it, but I don't know if I was loud enough that you heard.
Okay.
Thank you.
All right.
You want to end the live first?
Okay, let me.
Click on that and stop.